Hello students of class 9, welcome to today's class of atmospheric pressure and wind. That is chapter 4 and you have this chapter in your second term examination. Let us start with our chapter. Meaning of your atmospheric pressure. The force exerted by the vertical column of air per unit of area is called the atmospheric pressure. Okay, means what? Means the air that's fall vertically on the surface of the ground, okay, that exerts pressure. Okay, in 1 square centimeter the pressure exerts. That is your atmospheric pressure. Now you can ask me how. Air has got weight, right? So this weight falls on the surface of the earth and that exerts your pressure, and that is your atmospheric pressure. Now measurement of pressure. How do we measure pressure? The measurement of pressure is done by an instrument called mercury barometer. Okay, an instrument called mercury barometer. It is used to measure the pressure. Now there are two types of barometer. Firstly, we have got the 14 barometer. Secondly, we have got the Android barometer. Okay. Now, what is the unit? The unit used for the measurement of pressure is your millibar. Okay. It is denoted in the abbreviation of small letter m and small letter b. Okay. Again, I am repeating, the unit used for the measurement of pressure is your millibar. Isobar. Another new word is called your isobar. Now, what is isobar? The isobars are the lines that joins the places having the same pressure or same barometric pressure. If in India, if you have, suppose Rajasthan has got, for assume 40 degrees Celsius, Delhi has got 40 degrees Celsius, and your Ahmedabad has got 40 degrees Celsius, that will be denoted by your isobar in a climatic map. Okay. Now this is image is showing your barometer. It's a simple barometer instrument. This is how a simple barometer instrument look alike. It has got a glass tube. Mercury here, when the pressure falls, the mercury increases. Okay, and here there will be some readings where we can take the readings of the pressure in millibars. And this is how your isobars look like. And this is a map of USA. Here you can see 1016 isobar connecting the same places, that is having 1016, okay, millibar. This is 1016 millibar. This is 1016 millibar, and this joins. Okay, this line is telling you or telling us that this area are having same pressure, and this is how your isobar maps look like. Let us go to the next topic, pressure gradient. The decrease in pressure per unit distance in the direction in which the pressure decreases more rapidly. That is your pressure gradient. In simpler word, station A and station B. Okay, the difference of the pressure reducing in A and B, that is your pressure gradient. For example, again let us say in India, for example your India, in India example your Delhi, station A, and station B is your Meghalaya. Now where the pressure is reducing fast, the difference between the reducing of the pressure between Delhi and Meghalaya is your pressure gradient. Next topic we have got is your factors affecting the atmospheric pressure. What are the factors? Number 1, we have got altitude. Number 2, we have got temperature. Number 3, we have got water vapor. And number 4, we have got the rotation of the earth. First, let us see at the altitude. We will be learning more about in detail how the altitude affects the pressure. Okay, but altitude means the height. Okay, altitude means the height. Here it says the atmospheric pressure decreases with the height or altitude. Means if you go up, the pressure will decrease. How does it happen? It says the air in the high altitude is less dense than the air that is in the surface of the surface of the earth. Sorry, I repeat again. The air in the higher altitude is less denser than the air on the surface of the earth. Since the air have got lesser density, okay, the pressure will be less in the high altitude, whereas the air on the surface of the ground is having more density, means it will have more pressure on the surface of the earth. That is, when you go upper, the pressure reduces. When you come down, or when you go higher altitude, the pressure increases. When you come down to the sea level, the pressure reduces. Point number 2, since the atmospheric pressure is highly compressible, okay, the air is compressible, right? So since the air is compressible, the overlying layer after layer, the layer of atmospheres are there, isn't it? So that exerts pressure more, okay? Third one says the amount of oxygen also decreases. When we go to the higher altitude, the amount of pressure, the amount of oxygen decreases. That is why we feel difficult in breathing in the high altitudes, okay? And this difficulty is mostly experienced by the mountain climbers or the scuba divers, okay? Those who go for mountaineering high in Himalayas, they have difficulty in breathing. They have to take extra oxygen. Why? Because when you go higher, pressure reduces, plus your oxygen level also in the atmosphere reduces, and therefore we find difficulty in breathing. There is this called decompression sickness. It is also called the band. Now what is this decompression sickness? This decompression sickness is caused when we quickly move from higher pressure area to the lower pressure area, or lower pressure area to the higher pressure area. It says it is caused when one moves quickly from higher pressure area to the lower pressure area, okay? When we move suddenly, then we find the decompression sickness. That is why when the mountaineers go high up in Himalayas, they directly doesn't climb there. They have to wait there, they have to get used to of the climate, and then they move slowly, okay? We have to get used to with the pressure. Let's go to the next topic. It is your temperature. The next factor that affect the pressure is your temperature. What does it say here? Atmospheric pressure decreases with the increase in temperature. When there is an increase in temperature, what will decrease? Your atmospheric pressure will decrease, okay? Means if it's cold, the pressure will increase. When it's hot, the pressure will decrease. See, here it says, with the rise in temperature, the air temperature also starts to rise up. Why? Because the molecules which are tightly compact, it gets expand, it starts to scatter, or it starts to move apart from each other. Okay? The molecules that is in the air, when it's heated up, it starts to move away from each other, and hence what happens? It becomes lighter. And when the air becomes lighter, it starts to rise up. And when the air starts to rise up, it creates your low pressure. The decrease in temperature, just the opposite of the first point, please pay attention. It says the decrease in temperature, air temperature also decreases. Means if the temperature reduces, what happens? The temperature of the air also reduces. In this time what happens? The molecules of the air, instead of going away from each other, they come closer to each other, and hence the air becomes denser, and that causes your higher pressure. I'll repeat again. When there is higher pressure, when there is higher temperature, there is higher pressure. When there is lower temperature, there is higher pressure. Now, the equatorial region, okay, the equatorial region have got lower or low pressure belt, or it has got low pressure. Why? Because the sun rays in the equator falls vertically, and it's a hot place. What happens when the temperature rises? The molecules of the air moves away from each other, right? And it starts to rise up, and that it causes your low pressure. Clear? So the equator have got your low pressure, and in equatorial region it is having low pressure belt. Let us come to the next heading, that is your water vapor. There is another factor that affects the pressure. It says moist air exerts less pressure. When the air is wet, it gives you what? Less pressure than the dry air. Dry air will give you higher pressure. Yeah. Let's see how. Here it says the molecular weight of the water is lesser than your average weight of the air. It's very interesting. The molecular weight of water is lesser compared to the molecular weight of the air. Now, because of these differences, when the water vapor, okay, goes into the atmosphere and mixes with other gases, okay, what happens is the air becomes wet, right? And then the wet air, what happens? The weight of that reduces, the molecules reduces, the weight is reduced. Therefore, the humid air is less dense, and when there is less dense, what happens? It causes less pressure than your drier air. The air which have got less humidity or less water vapor will give you less pressure, low pressure, whereas your dense air or the humid air will give you more pressure. Let us come to the rotation of the earth. Okay, our earth revolves around its axis, isn't it? Now, this rotation of the earth also plays a very important role in determining the factors, in determining the pressure, sorry. Here it says, due to the rotation of the earth, the wind from the polar region, okay, we have got two polar regions, North Pole and the South Pole. So, the air in the wind from the polar are pulled towards the equator, and the wind that is in the equator are pushed away towards the polar region. The equator region is warm, right? Equator region is what? Your 0 degree latitude. So, it says here, the equator region is warm, the air expands. We have already explained it. The air expands when the air gets warm, the air expands and it becomes lighter and it rises up and it causes your lower pressure. Now, the polar region is cold, right? The polar region is cold, therefore, air is compressed. Since the air is compressed, okay, the air becomes denser and it exerts or causes high pressure in the pole. This all happens due to the rotation of the earth. Now, let us come to the next topic, that is your world pressure belt. The world is divided into different pressure belts. Let us learn about them. What are the different pressure belts we have? Firstly, we have got the equatorial belt of low pressure. Secondly, we have got the subtropical high pressure belt. Thirdly, we have got the subpolar belt of low pressure. And lastly, we have got the polar belts of your high pressure. Now, these are the four pressure belts that is distributed all over the globe. Let us learn about them in detail. Okay, this image is showing you where these pressure belts are. The region here, the red zone or the redly marked part, it is your equatorial low pressure zone. When you go higher, this is your subtropical high, subpolar low, and at the end we have got the polar high. It is the same in your southern hemisphere, okay. Whatever we have the pressure system in the northern hemisphere, same will be also having in your southern hemisphere. Please look at the image properly, read the image properly for further understanding. First, we have got the equatorial low belts. Now, this equatorial low belts extends from 0 degree to 5 degree north and south of the equator. Okay, from the equator, if you go 0 degree to 5 degree latitude, you will find this equatorial low pressure belt. Now, what happens in the equatorial low pressure belt? As we know, the sun rays falls vertically in this region and causes intense heating. It's very hot in the equatorial region. Because why? Because the sun rays falls vertically. Since it is hot, again the air will expand, it will rise up and it will create your low pressure. This equatorial region, low pressure belt, is also called as your zone of total calm, or it is also known as your doldrums. Now, subtropical high pressure belt. Subtropical high pressure belt. Okay, so it extends to 30 degree north and south of equator. From the equator, if you go down to 30 degree latitude, north and south, this subtropical high pressure belt will exist there. It is also called as your horse latitude. Now, from this subtropical belt, the wind blows into different directions. Let us see. The wind that blows from high pressure to low pressure towards the equator, okay, the wind that blows from high pressure towards the low pressure, towards the equator is called your trade wind. Same way, the wind that is blowing away from the, and the wind which blows towards the subpolar low pressure is known as your westerlies. I am repeating again, the wind that blows, okay, from the high pressure to low pressure towards the equator is called your trade wind, and the wind that blows towards the equatorial low pressure belt is known as your westerlies. Next you have got your circumpressure belt, circumpolar low pressure belt. It is located between 60 and 70 degree, okay, north and south latitude. Now in northern and southern hemisphere, in both northern and southern hemisphere, you have this circumpolar low pressure belt. Now the descending air gets divided. Here also what happens, the air descends and it gets divided into two parts, okay. One blows towards the equatorial low pressure area and the other blows towards the circumpolar low pressure belt. Next point you have got, the warm subtropical air blows over the cold polar air, okay, blowing from the poles, and this is the reason, this is the place where both cold wind and the warm wind comes and meets together, okay, and this place is having violent storms in winter, okay. Here is the place where both the cold wind and the warm wind meets together in this circumpolar low pressure belt. Let us come to the polar high pressure areas. Now this is located in the poles, the northern and the southern poles, that is 70 degree to 90 degree latitudes. Now the region always experiences extremely low temperature. As we know, in the poles is always cold, okay, therefore they experiences what? Extremely low pressure or low temperature there. Mostly it is what? Covered with ice. That is, it is characterized by permanent ice caps. It is covered with ice almost all the time. And since this region is cold, what pressure will it have? Low or high? It will definitely have your high pressure. So in the polar regions, we have got the high pressure belt. Okay, so for today, we will be learning only till this much, till the pressure belts, the wind and other stuffs will be coming to the next class. Okay, thank you.